Welcome to this new tutorial on neural networks for architects, and I will give you a short intro about the scheme, how to set up and how to organize the networks around self-driving cars. So let's go into it. We will work with very few numbers just to give you an idea of how to deal with that. So it's not about problem solving. Nobody knows what car driving is because our environment is this complex and our behavior is very complex. So, and what you will see is that we kind of have to embrace these conceptions. You don't have to stick it. This is what artificial intelligence is doing. It's not addressing certain problems. It's kind of embracing it, and by that it works in all environments, and that's it. So it's more a shift in how to think or how about our existence in the world beyond problem solving. This is what we kind of address and implement here. So there is a proper reference. It might be interesting to see. Here, this guy, he's doing simulations with game engines to...
we trained this vehicle in all of these, this vehicle in simulation, maybe 10 hours to go through all of this data beforehand, and it learned.
So then he went beforehand with simulations, and then he took this neural network to run in actual environments, and this works pretty well. So that's I think very interesting. So we do the same, just with very few numbers, but the same principle. Instead of having a camera, we have a kind of synthetic LiDAR system, a 3D, a 2D radar sensor. So, but I think what you can learn here is how to think about a coexistence with artificial intelligence in real world, which is at stake with architecture. So have a closer look. I made it as simple as possible. So we have two entities, the environment and the car. So it's not working, unfortunately. I have to put that it's not working properly on the net. So you have to download it to your desktop. Again, these errors, ignore them. So go with the environment and the car. We have the environment, just two lines. There's a car, a small rectangle, and this is how to render that. Put the car at a certain position within an environment, and we will change the environment later. Now there's a sensor of this car. This is the program. It's unfortunately it's complicated to make it fast in large environments. Then, yeah, it's so. But what this sensor is doing with the car at this position and looking in this direction at within the environment, that gives in this case 16 numbers. You can increase in numbers with this parameter here, with this here. So it's circled by 16. So we get 16 numbers, and you always have a rule. So this is no obstacle. There's an obstacle at 0.87. So it's near, then there's no obstacle, and so on around. You see it here. And then we get the graphic information. So this is the center of the car. You see it here. And then where the LiDAR meets an obstacle of the environment. So this is the length, and this is the graphics. So which means we can get a certain point, a certain direction. This is just with a semicolon. This is just evaluated. There's no effect to the graphics. Environment, get the LiDAR to this point and draw the car on the same point, and this creates the car in an environment with its sensors. So what we are now doing is if you just drive in a simulation, the key problem is that you only drive well. So therefore the network will not learn how to react in critical situations. So therefore what we do is we go for a spectrum of samples. So all the situations which might occur, in this case the car could be any kind of, look in any kind of directions, and then we say what to do. So we always have sensors and then say a kind of prediction or decision to do to change the direction and to change the speed. These are the actuators. So setting it up. So we have a point. We do it with certain random, the point and the direction. Then we have a target. The target is always that we want to be this distant from the left side. This is our target. And then we have the leader, and that's it. So, and the calculation, what to do, we do it this simple. We just try to move in the direction of the target. We always put the side, the direction of the car towards the leader, and the speed is if you have wrong discrepancy, it should be slow. If you're in line with the target, you can drive fast. Super simple, but now you see it's like this, and this is a spectrum of situations. So, and now this is what we have. We have the input. These are the sensors. This is, in this case, the leader. Can be cameras, can be whatever. And this is the output of our situation. This is what to do with the proper driving. You can do that with the game machine, and you can do it like with this video while driving in a simulator. Then the simulator can put you in critical situations, and then you do the appropriate things. So we're doing it with this simple setup here. Now we create, like always, a set, in this case, of 1,000 of samples. This takes a minute because of this collision between our leader and the environment. This is always intensive in calculation. Okay, now it's done. Split the data, and now the network. So this is a set of we have data T of 1, and you see this is one of our sets. We have now 100 and a similar setup. So if the leader says this, do this. Network, very simple. We have the LiDAR is with 16 dimensions, so we go with the linear layer with 16. We have an input with 16, go with a linear layer. We discretize it to be able to fold another layer, fully connected layer with 16. Then we localize it as discussed before, go down to 8, then go down fully connected to 2 because our output is 2. We have this connection, input 1, 2, 3, so we can skip that if we make a net chain because there's no, the graph is just a chain. So go here, create that, see that in a graphical way. So we can now test it. We can ask this network with the data, with the input data, the sensory data, and ask what to do. And he should deliver the direction and the speed. This now is random. We do not have to show that, so we'll do crazy things, nothing. Now we train the network with the data, training data, and take data V, the unknown things, as validation set to check the quality. Now it's learning properly. If these curves are different, so something is wrong with your setup. So if this now goes separate. So the performance to an unknown situation is this blue one, is the validation set, and now we are here. And now we can run, very simple, with the data V, we can run it, and this should be appropriate action and decision what to do in this situation. So that's it. If we want to see that, this is how it is done. We integrate now in our graphic here. The prediction is with this network, with a trained network T. The rest is kind of similar to what we've seen before. And now we see if we are here, the car should drive here because this is our target. So if you have another one, so it turns a little, goes there. And you see it's working properly. Now it's getting slow because you have to turn. So that's how it works. Now we can simplify that. We have this function car move next. So which means if I at a certain point in a certain direction, what to do. The next point would be here, and the next direction would be here. This is dirty, very important. You should not do this, but for simplification, for simple setup in this tutorial, I just had this global variable just included and wrapped in this as a side effect in this function. You should not do this. So in principle, you should have the parameter environment here as well. So if we want to show it as a graphics, now it's working like above, but it's clear now how it works. We have the car, and then the next move is the car in a single line. So it's more so. And now we can start with the unknown environment. This, for example, you can start here with a line of a road somewhere. And the interesting thing is that this car, now, if you put it on the road, is working properly. And you can animate that. All this is not optimized for speed, just for clarity in the way how to think. And now you see the car is, he never see this road, he never seen a curved line. We trained it interestingly with this, just in this situation. And now he's able to run in the proper way, always with a certain distance to the right lane. Now we can do some recording. This takes again to animate it. This again takes some time to calculate. So now we have a record of points and directions, and we want to animate that. We see the car driving and getting crazy if there's no road. So that's it. Thank you for watching, and see you in the next tutorial.